So a prize wheel used for a game shows an electronic, or a game show, sorry, has an electronic motor that allows a circular wheel to spin at a constant speed in the clockwise direction until contestants press the stop button, which is not shown. The center of the wheel is 30 inches away from point A. Okay, so I would go ahead and start labeling some on my graph. This is going to be 30 inches. You need to be paying attention, please. Okay, at time t equals 0, point A is at the lowest spot on the wheel, and the distance between point A and the level table is 15 inches. So from here to here is 15 inches. The wheel completes 4 full rotations every second. As the wheel spins, the distance between point A and the table, so all of these distances are from wherever the point A is in the table, changes or periodically increases and decreases. Okay, so we have this model D that gives that distance between point A and the table. So we know that there's 4 rotations every second. Is that the period? Does that mean the period is 4? It does not mean the period is 4. The period is how long it takes for one rotation. So when it tells you 4 rotations every second, what they're actually telling you is the frequency. So what do you guys think about the period? Like, how long is it going to take for one rotation? Quarter. 1/4. The period is always going to be the reciprocal of the frequency. And we will talk about that again. But the period in this case is going to be 1/4, which I'm going to do this one using fractions. I'm just going to make up like a partial one on the back and show you how to do it with decimals. And you can choose, bless you, either one. I like fractions way better than decimals, but I know probably you guys prefer decimals. All right, so let's figure out these heights. So the height is, we're looking at the height from point A to the table. So when point A is closest to the table, which is this point right here, what is the height of 15? All right. And then there's going to be a time when point A is here and here. That's like the middle. What's that height going to be? All the way to the table. Yes. Nobody got that at first in my other class. And what's super helpful for me is to understand that going up, these are always going to be equally spaced. And so I can tell here it's going up by 30. And so I'll just go up by 30 again. All right, any questions? That's going to be the height at the highest point, which is when it's right here. So it's 30 plus another 30 plus the 15. Okay, and then this is kind of like where the one I just talked about from the assignment. Is point F, when A is at 75 inches, is that at time 0? No, at time 0, the point is closest to the table. So I'm going to continue my period out. This is going to be time 0. A full period is going to be closest to closest. So that's going to go to J. And we already decided that our period was 1/4 of a second. All right, so what is halfway between 0 and 1/4? Yes. Now those of you that do a whole lot of measuring things, this problem you're going to dominate. You're not even going to think about it. Those of you that don't really like fractions and probably don't ever measure, anything is you might struggle a little bit. Okay, so even though right here isn't an actual point that we need, it's going to be helpful if we figure that out. So what's halfway between 0 and an eighth? 16th. Good. And that's why people who use rulers or tape measures, this is 16th is how they kind of do the increments. All right, so each increment is increasing by a 16th. So when I go to find this one, I would just take the 1/8 and I would add a 16th to it. So say it again? I didn't hear you. Yes. And so to be able to add those, we need a common denominator, which is going to be 16. And I'm doing this like you guys are really bad at fractions. If you're good at fractions, just ignore me for a second. And so I need to change 1/8 to some number of 16ths. And to do that, you would just multiply the numerator and denominator by 2. And then you add that, and that is going to be 3/16. Okay. Now I need to be able to go all the way to P. So I have a couple more points I need on this horizontal axis. And so I would do the same thing. I would still take the 1/4 and add a 16th to it. So that's going to be 4/16 plus 1. Right, and then I would do it again. You might be able to see a pattern that it goes from 1/16 to 2/16 to 3 to 4/16 to 5/16. This one would be 6/16. And I think they would take that as an answer just fine. It does reduce to 3/8. All right, now we really don't need these guys over here, but it was helpful to use them. So go ahead and use these values and these values to find the coordinates for F, G, J, K, and P if you haven't already. And then we are going to just look at one little section from F to G. All right, so B1 is always asking about what's happening with the Y values of D. So looking at the Y values in that section, what do you guys think? Positive, negative, increasing? Positive and decreasing. All right, and then part 2 of B is all about the concavity and what the rate of change is doing. So what do you guys think? What is the rate of change doing? Decreasing. And you technically only have to write decreasing and you will be fine, but if you want to make it good, any questions on that one? Okay, so on the back, I'm going to show you a similar kind of situation, but we're going to look at decimals. So let's say you're doing a problem and you know that the period is 1/25th. And you decide you don't want to try to do fractions here. You would rather just do decimals. How do you change 1/25th to a decimal?
0.5.
No. How do you do it? Don't tell me what it is. How do you do it?
You change the value to 100. You try to like put the decimal.
Oh, you could do that. You could make it over 100. I never even thought to do that. Most of the time, when you want to change a fraction to a decimal, just take the top and divide it by the bottom. Take the numerator and divide it by the denominator. Although, what David said is true. You could make this something over 100th, and then like write what that is in hundredths as a decimal. That will work perfectly. If you want to do it this way, though, you would put okay, so what do you do if the divisor is smaller than the dividend? You add a decimal point and then 0. Still too small. Hit another 0. And then what do you get? 0.4. All right, so let's say that we're starting at 0 and we're going to 0.4. Nope, 0.04. All right, what's the halfway? Yeah. And then the halfway? Yeah. All right, so if you prefer decimals, the two we're doing, they're fine to do by decimals. I did the first one by decimals, and a whole lot of my students did fractions, and I was like, this is easier to do by fractions. So you get to choose which ones you want to do. Now, I'm going to give them to you. Part B, I'm actually going to change the wording, because I like the problem different if it's not the way it's originally written. So we'll fix this together in just a second. Okay, so this first one is about the blades of a motor boat. And they give you two pictures, which confused a whole bunch of people last period. Really, for me, the only one I really needed was this one. So this is the whole problem is talking about a point on the blade, and we're changing it to the water depth at different times as it spins, okay? So for me, you can just not worry about this guy and just look at this. All right, what we're changing, Brian Passwater initially had this problem be the distance that point B is from the water line, but I'm gonna make it a little different and have it be the depth. So here where it says the distance between and the distance between, let's just change both of those to the depth of point B. And we don't really need the water line. So what do you know about depth when it's below the water level? It's negative. Okay, and so this motor is never going to be above the water line. And so all of our depths for point B they're going to be negative depths. All right, and before you get going too far, pay attention to where the starting point is. Like, this one doesn't necessarily have to work out like the one we just did. All right, so if the starting point is like actually at F, then that needs to be 0 times 0. Anyway, I'm gonna walk around as you're working on this and just make sure that you're getting things right, that you don't get too far with something that's wrong.